Hi there and welcome back to the channel. Today on the bench is a little Sanyo colour portable television. I picked this out of a trash pile. It was being thrown away, and this is a Sanyo, what is it, a CTP1101. That's a Sanyo CTP1101. It's from the 1970s. It just caught my eye as being very cute looking, very 70s looking, but also unusual for a 70s TV, again a colour portable. I thought it was black and white, but actually when I saw that they had a colour symbol on it and colour controls, I thought, oh, that's interesting. Yeah, okay. So it's had a bit of a bang. It's got some cracks in the plastic here and around here. It did come with a, I believe it's a 12 volt power adapter, so you can plug this into a 12 volt source, like a battery, car battery, whatever. So yes, that's quite unusual to get these. These are normally lost. So let's have a quick look around of it. It's a rotary UHF tuner. We've got a bit of a broken on-off button here and a volume control. AFT control. I think that might be the speaker there, I'm not sure. Actually no, speaker's there. Couriers always turn up at the worst moment. Literally, it's yes, something I can unbox later. So where were we? So yes, so this has got a UHF. I think this might have been VHF, because there would have been a VHF symbol there and the rotary dial there. Let's turn it around. It's pretty manky and dirty. I think we've got a speaker here. Then on the back here we've got looks like colour, brightness, contrast, vertical hold, horizontal hold of some sort. Then we've got we've got a nice little aerial here, which oh god, might be working. I don't know. To find out. We've also got a handle here. Oh, come on. There we go. Which seems pretty sturdy. On the bottom here we've got AC power, and this is 240 volts, 50 hertz. RF in, DC 12 volts, manual degaussing, so it's an intermittent switch there, and then automatic circuit breaker push to auto. So yeah, that's all right. Underneath is pretty much nothing. Looks like somebody has been in here. The serial number here is 37207653, if you want to play along with that one. It is very dirty. We have got a crack here across the bezel there, and that's looking like it's a bit loose. We've got a fairly substantial crack across here. Again, I can repair these, that's not a problem, that's fine. Yeah, let's give it a clean actually. Yeah, I have got enough cleaning, so I'm down to my last little bit of cleaner. Got some more coming in. Oh, that's going to take some cleaning. It's not rubbing off. I thought it was just more grime, but actually that feels a little bit manky. Yeah. And let's give this a clean. And yeah, some of this is dust, some of it isn't. It definitely has been through the walls, I will say that. No idea whether the tube works. Nope, it's not been powered up. Not one. I've had it. Yeah. There are a number of cracks in the case. It's quite a crack fest. This is very, very dirty. Let's turn that around there. It's a little bit cleaner than what it was. Let's open it up. Oh yeah, we've got to be careful of that. Control is already a bit loose, so we're going to have to... Oh, we have... Let's have a look, see whether I can see it. We have a transistor's location inside. They stopped doing that many years ago. Made in Japan, no dates, codes at all. I can find a 250 AFB22. So I'm going to get the tube tester out. I've been having problems with the tube tester. It's been playing up, so I won't give 100% faith in the tube tester, but we'll certainly give it a go. It's very dusty, pretty simple by the looks of it. Already seen the power board, the deflection board there, tuning, power board, flyback. Can we get this on its side without breaking everything? This case is very, very bad. So is that. It's very cute. It is very, very cute indeed. Inside. Okay. Let's get the tube tester out. Let's see what state this thing's in. So, what was it? 250 AFB22. 250 AFB22. Socket 25. Socket to 25, 6.3. Do we have 25? 6, 3, 21, 19. No, we don't. So unfortunately we can't use the socket test, the CRT tester. Oh well, that's fine. So, what do we do with it? Well, I think we just bang some electrons into it, I think. I really do think we just have to go for it. We will be using the CRT tester. Sorry. We will be using the dim bulb. We'll put it on load. I just want to check that. Power switch, yeah, it's just loose. Either be a bang or there'll be absolutely nothing. Or we'll get a picture, either one. Let's put that, yeah, that's down at 21. Do I want to do it? I'm actually going to power it on like that and turn it on there. So, because this is a little bit wobbly. Here we go. Let's see what happens. 3, 2, 1. Nothing. Absolutely nothing. So, okay, let's just make sure that we've actually got power going in and it's actually connected. Oh, come on. Knotted cables. That's it. So, do we have power going into... this is going to be a hot chassis, I think, so... No. So we're not getting anything in on those terminals. That's interesting. So okay, I'm just going to check the fuses. There are 2 fuses in this, I can see. So I'm just going to, yeah, we've got on that one. No, we have continuity on both of those. Do we have continuity on this fuse? Yeah, so the fuses aren't blown. Oh. Right. It might be this has to be in. I've had this before. Basically, these act like a bridge between the two. I think so. Let's put this in. They're not touching, that's good. Let's put that back in. It's interesting how there's no continuity between the AC power supply and the connections. What we could do is, I do have a battery. We might power this up. Let me go and get it. There's a motorcycle battery. I think it's got some charge in it. That's positive. Let's move all this out of the way. That's no. Do we have the battery power? Yeah. So I think what we've got to do is we've actually got to start diving into here and seeing why we're not getting power into this board. I think it is this circuit breaker switch here that and we might have to bypass that. So okay, let's start to take this thing apart. So I've been doing a bit of dismantling to try and understand how this is all connected. Here we've got the AC power, and that runs through to the back of this connector here. So from all the way through there to there, and it presents the negative and the positive. It presents the live and the neutral to those 2 pins. Now you'd think that this connector here might bridge them, and it doesn't. This is designed for 12 volt. That's connected up to my bench power supply, and the 12 volts comes in on those 2 pins just there. And when you connect these, they're not connected. There's no continuity at all between these pins. These are designed simply just to connect in and isolate. And because this is actually the 12 volt cable, what would have been here for AC operation is a connector like this, but without the cable. And that would have then basically bridged between these 2 to those 2. So let me just go in there. So gone from those 2 to those 2, direct across. So that's why the AC wasn't working. And then, okay, I've applied 12 volts to these 2 pins. I've got it running up. I've had it from the battery and it didn't work. And I've got my bench power supply up there, my little one. And so I put 12 volts through this and I traced it. It's getting to this circuit breaker here, and this doesn't work. This doesn't work at all. So when you do that, it's just not bridging. And again, that red wire goes to the positive from the 12 volts, goes into the circuit breaker, and then that goes across and it runs all the way up to the switch over there. And that switch does both AC and DC switching of on and off. So that's how this thing actually goes between 12 volts and AC, mains power, is that it's this connector here. And I've had this before where I've had some TVs where you've got this on the back, and if you don't plug it in, you can't, if you haven't got it, then the TV doesn't work. So what I'm going to do is I'm going to run the 12 volts in because I can monitor it with my current meter here. I'm actually going to run it the power into here, and then I'm going to bridge across this circuit breaker. Now Shangu does this over in the States quite a bit, and you see it, and I do wonder how hot the cables get, especially when there's a short circuit. So the only way I'm going to know if there's a major short circuit is if the bench power supply actually gives out, or I exceed the bench power supply's power. So who knows? It is what, about 40 watts at 12 volts, so that's going to be, that's going to be about 5 to 10 amps. This thing only gives out 2, but at least we're proving it. That's the case. If so, I can go to that, and in fact what I might do is actually put a little I've got a fuse holder, and I might actually put a 10 amp fuse in line with it, just to protect it. So, but yeah, I think this circuit breaker, and this circuit breaker only works for the 12 volt line. So yeah, so we've got a break here, and we've also got that. So I'm going to try the 12 volt first and see whether we get any life out of this TV, and then move on to potentially the AC, bridging the AC across there. Okay, so I've got some clip leads. These clip leads might get hot if there's a short, so it's going to be interesting. So okay, I'm basically shorting out the circuit breaker. We'll soon see. I plug that in. Okay, that's turned off. Let's turn the power on. Here we go. I've also plugged the speaker in, so we might get a crackle from it. Here we go. That pretty much, yep, shorted out the power supply. Yep. So I think I better put a fuse in line with this. I can see this melting cables, and very quickly. So right, okay, let me just sort that out. This lead. So we're now hot with the cabling. That's off. Let's see what we get. Okay. Do we get anything at all? 1, 2, 3. Nothing. Nope, nothing's working on that either. It isn't working. Oh, that got hot. Oh, toasty. Oh yeah. They got toasty. Oh, that's why. Okay, so yeah, hot wiring the circuit breaker didn't work. I ended up overheating these cables. There is a short on this, so what I'm going to quickly do is just show you the actual short itself. If we go here and we go, let's actually bring that into shot so it's a little bit better. Yeah, so let's have a look. Yeah, that's all good. So if I put that on there, and then either put that on there, right, we've got 5 meg ohms. Turn the TV on. Yeah, we've got 1 ohm, and that's on the negative of the battery terminal and the positive on the other side of the circuit breaker. So yeah, we've got a short. I've done the same with the mains, and we haven't, and I will just check that right now. So if I just use this clip lead just to clip on there, and we then, oh actually hang on, yeah, I need to go on the other one, don't I? And that is that side. So if I then touch there, we've got so that's off, and that is power switch on. So 3.3 megohms. We might still have other problems, but at least it's not shorted. So what I'm going to do is just put that to one side. Is I am going to use a clip lead to basically bridge between the two pins, and so that we can test things. So if I just do that and I do that, so we've got one clip lead doing that. This is all really janky. This is Shangu style. I love Shangu. Sorry. I love him. Don't like his politics, but I love him. I've got to get this right. Come on, come on, come on, come on. There we go. That's a bit better. And let's see what happens. So I'm going to move you back to the other side of the TV so you can see what happens on screen. And let's see what happens. So I'm going to power on. We are on load rather than bypass, so this should go through the light bulb. Let me just bring you up. That's better. That should show you the bulb up there. So that bulb will light up if we've got a short. And in fact, what I'm going to do is I'm just turn that light off. So we've got a bit of darkness there. Power is applied. I've got to be careful because it is actually live here. Here we go. 1, 2, 3. Something's happening. Is something happening? We're getting 46 watts. 46 watts. When are we getting anything on the screen? Yeah, we do. Oh yeah, we've got something. We have something. That looks good. Yeah, that looks good. It's a bit scratchy. The pots are really scratchy. Okay. Let's put. Oh, I can't put a video source in because this is just so bad. But at least we know the TV actually does work. So what I'm going to do is, if there's a short on the battery side, I just can disconnect it. I just don't need to do any of that that side. So what I'm going to do is I'm going to basically take those connectors and cover them up, and then I am going to essentially bypass this entire whole socket, because we don't want this plugged. So we may not want this thing plugged in all the time, but I don't want this live here. Some people putting things in it. So yeah. So what I'm going to do is I'm going to basically unsolder all of these, or even just cut them out. I'm still going to put the connector on there just for show, but that will be completely bypassed. Yep. Okay. Cool. Right. Let's get on with it. Power's all sorted. Disconnected the 12 volt. That's now dead. Don't have to use it. That's the speaker there. I've got an RF feed into the TV. Let's go for it. Let's see what happens. So let's put it on load first. So power is applied. Let's pull that out, and there we go. We have got a picture. Let's see whether we can. There we go. We've got a picture. Oh wow! And it's colour. These pots are really scratchy. Oh wow, that is really bad. Okay, let me just put you on to 50 Hertz so you can actually see what's going on. There we go. We do have a picture. No sound. The pots are really scratchy. Yeah, that's really scratchy. let's just put, yeah, let's get some WD-40 on those connections. Let's just get that all nice and cleaned. That's good. Yep, the colour's all good. That isn't a bad picture, really, is it? So we've just got an audio fault, which actually we can try to. Oh yeah, there we go. That's pretty good. So pretty good. So if I turn the other TV up, which is that way, you'll hear some of the audio.
Sure I am. Yeah. Have some sweetening for your morning coffee.
Right, let me just turn the overhead lights off. I'll turn that one on. Yeah, quite reasonable. Quite reasonable. Colours look great. Linearity looks fine. Yeah, not bad. Not bad at all. Looking at the chassis, I thought I'd turn my attention to the on-off switch, this thing here, and it just looks like the nut is loose. So if I tighten that up, I use my finger. I will use a pair of pliers or something like that. That's actually started to tighten up. So yeah, I'm just going to tighten up that nut and yeah, just get it all nice and solid. So that's now lovely and solid. I've turned it up quite as much as I can dare with the plastics as they are, because the plastics are quite old. So yeah, that's lovely and solid, and now works as intended. So I've been fixing the plastics on this. I've already super glued it so that it's all in place, and I'll show you this side. So yeah, that's all super glued back into place. Now super glue on its own, there we go. Yeah, go on, zoom in, you bugger. There, hang on, there we go. Yeah, so super glue by itself won't really hold it. It's sort of actually quite weak. But as shown on my channel before, I'm using the tried and trusted method of using bicarbonate of soda and super glue. So what you do is, if I can just get this in the right place, you dribble some super glue down there, and you then pop a bit of bicarb on. That's quite a lot, but I'm doing this single-handedly. Yeah, just cover it all in, and this then creates a really strong mechanical connection. And then once you're done, just tip. Oh yeah, it does go. It does tend to go everywhere. and with a quick brush, that's actually made a fairly strong and quick mechanical connection on it. And I've done there all round that joint there, and also all round where it cracked on this corner of the screen. I might do a little bit behind there as well. Hopefully that won't interfere with the putting the panel back in. So yeah, I've also noticed that that particular screw hole needs fixing as well. So I'm just trying to get all this solid so we can put this tube back in and then start getting on with fixing the audio. Just my luck, I get this little TV back together again, and what have I done? I've forgotten to put the degaussing coil in. So I've got to take the whole thing apart again, including taking the tube out, and put that back in. Oh, what a pain in the backside. Well, this isn't the BBC, so I can say the word fuck. Yeah, there we go. It might even actually subtitle it out. So I've got the TV back together again. It took 3 attempts, all down to that degaussing coil. On the second attempt, the degaussing coil cable cut across the thing and I didn't notice, so the tube wasn't flat on the bezel there, and I put the whole thing back together again and realised what I'd done. So I had to remove, I don't know what they're doing to that rat, anyway, I had to remove the whole lot again and then reseat it. So yeah, it's not bad. The picture's pretty good. There's a little bit of purity issues, but nothing too major. Still no sound. Nothing at all. The other TV is got sound on it, so yeah, nothing at all. So I have checked the IC for the transistor for the audio amplification, and that seems to be okay. So I think it is something somewhere else. So I think what I'm going to do is I'm going to look for another project, and I'm going to put this to one side, and I'm going to come back to this one because I've got so many projects to do. At least I know it works and it's there. Yeah, my hands are dirty, and it's actually there and doing something. So it's a good starting point. Okay, so I'm trying to trace the audio problems with this little Sanyo TV, and it's I've got no service diagram, so I'm having to sort of work it all out myself. So we've got the audio transformer here. These cables go down to a power transistor here, which I have checked. So it basically goes to 3C3, actually no, it goes to 3C3 and 3VT on there, and that looks like it gets power from the B+. Then you've got this connection here, 3C1, that goes back up to this. Let's see whether I can get some better light there. There we go. There we go. So it goes to this connection here, which is, if the phone will bloody well, that's better. There we go. So it goes to this connection here, IC1, and then that goes up to there. There's a bridge solder, so you can disable the audio as well, which is interesting. It goes to that resistor there, then goes back up to here, and then goes off into the audio side of things. It also, by the looks of it, is connected down here to this capacitor here. I have replaced that one, and that runs all the way through to the ground on here. It looks like ground anyway. Goes to this little transformer, which then goes to the IC, which does the audio amplification. Yeah, it's really odd. Yeah, I'm struggling to find a course. Now, when you plug the speaker in, so there's the speaker, you can hear audio, but it's really, really, really quiet. I mean, like, ultra quiet. I'll see whether I can actually get some audio from the speaker for you. Yeah, it is pretty quiet. So, if I put 1.5 volts AA battery across the terminals here, I get a bump from the speaker, so I think the speaker's fine. Now it could be the little transformer here. Everything seems to test okay. So I've checked the resistors here, resistor going up to here. I've checked the resistor going there. That's all within specification and the colours. That resistor going across there is fine. Nothing's being pulled down to ground. I've reflowed a lot of the connections here just in case. That capacitor, yeah, that is absolutely fine. Tested that. Tested that capacitor. Tested that capacitor. Tested these resistors here. All these are all done. I've checked them and they're definitely within specifications. Replaced this capacitor here. Electric capacitor. That's absolutely fine. I have taken the chip out of its socket and put some contact cleaner in and put it back in. Still nothing. You can hear audio. You can hear it. It's just dead quiet. Really, really, really quiet. I've put the oscilloscope on, by the way, and I'm getting about... Where was it? Yeah, I'm getting about... where was it? Yeah, across the speaker connections here, I'm getting about 200 millivolts. 200? No, 100 millivolts across that, which goes out to the... Sorry, this is not the speaker connection. This is the out to the volume control. So I'm getting 200 millivolts across that, and you can see that the wiper arm on the pot is working because when you turn the volume down, it goes down very nicely and comes back up. So you can hear the audio. There is definitely audio there. So the demodulation of the audio, the carrier wave, is being done. It's definitely working. It's just not amplifying properly. And again, the amplifier IC, the transistor, is down here. That tests absolutely fine. There's voltage on these. So it is working. There is stuff there, but I just can't seem to find the right point where there's a fault. I'm struggling to find a fault. Everything seems okay, except that the output's bad. So yeah, that's where we are with this little TV. Otherwise the picture's perfect on it. Just no audio, or audio you can hear anyway. It's really, really difficult to find the issue. It is definitely... That's definitely working. That's definitely got power, and it's... Yeah, when I put the oscilloscope on there, I'm getting the right voltages and I'm getting the right waveforms. And it's sort of the same up here. When I actually put the actual things, I'm getting the waveforms, but they're incredibly low. Yeah. Oh well, I'll just keep on watching more Mission Impossible, and I'll just keep on working my way through. Right, let's connect to here. There we go. So that is across that resistor, using other points, but it ohms out to correctly. Yeah, it just seems unstable, and it was in the mega ohms. So I've been working on this little TV for some time now. I've been struggling to find the exact cause. What was happening, I could just about hear the audio. I had to put my ear right up against the speaker, and it was clear, and the volume control would actually turn it all the way down. You had to turn the volume right up to maximum, and you could just barely hear it, even with my dead hearing. So yeah, it took me a little while to sort of work out what was going on. Let me try to show you what was going on. Let me just try and see if I can zoom in. This is the audio amplifier IC here. It's a little TO package. And I was tracing the cable. So again, the speaker is actually connected directly to this. Well, actually not directly. It actually goes to the transformer up here, and then it then goes out to the speaker. So yeah, I was tracing it through and using the multimeter to basically work out where the voltages were. And on the collector here, I was only getting 2.9 volts. That is a 2SC1507, and the maximum voltage is 300 volts. So there was 2.9 volts coming in here, and so we've got a capacitor here, and it's a ceramic one, and then we've got a VDR, a voltage delay resistor here. And that comes across to this trace here, which then goes up to this jumper, then to this capacitor, which filters, and then it then goes to this resistor here. Then this resistor gets its power, and on this side was 78 volts, on that side was 2.9. So I traced the voltages here, so the 78 volts, all the way down through to the big cap there, and all the way down, further down here to the transformer, and so forth. So that was fine. But it was this resistor here. Now, that resistor, if I can grab it, was this, and it was showing 145 kiloohms on it. And when you actually had it in circuit, it would go into megohms. If it got hot, it seemed to stay stable at 145, but as soon as you put it in and powered it up, for ages afterwards, it would be in the megohms. Yeah, sorry, my phone is hunting like crazy on focus, so sorry about that. So yeah, this seemed to be bad. So I've got no circuit diagram, so I started off with a 47k, and suddenly I could actually hear a bit more noise out of the speaker. And then, where is it? Then I tried a larger resistor, not this particular one, but it was a larger one, that one, and it got louder. And then now I've got in, and I actually paralleled across the actual resistor here, rather than actually try to take it in and out all the time. Very Shangu style. And yeah, I managed to get quite respectable audio. It's a little bit low, because I had a 47k in there and I had an 1800 ohm. So I've taken the 47k out and I've just got the 1800. So I'm going to try that, and let's see what volume levels we get from the volume control. But I think this is the problem here, is that the resistor's gone open and it's not powering the collector of the audio amplifier, and there's just not enough voltage, and you're barely hearing it. So yeah, it was an interesting one. Just sort of trace it through, and one of the things as well is that I also have traced the volume control out here, and also I've done the audio board there. I've even actually also replaced a chip there. There was a chip there which looked a bit suspect, and to be honest with you, it was very intermittent. So that chip just there. So when I was pushing on it, it was popping in and out and all sorts. It was very odd. So I put a new one in and it's been absolutely fine. It was pennies, so it wasn't exactly expensive to do. I've also replaced a number of the capacitors here. There was, where was it? These two here, 10 microfarad at 250 volts, and a few others around here, which were really out. They were nearly double the capacitance. So this thing does need a full recap. There's no doubt about it. Even the bigger caps are showing signs that they're actually going out of spec. The smaller ones definitely are. So okay, let's plug the speaker in and let's hear what the audio sounds like. Speakers on top. Let's pull this out, power's on, and let's wait for the picture to appear, and then we'll turn the audio up. So this is just an 18 ohms at, I think, 1 watt or 2 watts, something like that. Okay. Oh, it would help. It would help if I actually plugged the bloody thing in. Oh dear, okay. I'm getting old. Let me just do this, it's a two-handed job. Hold on a minute.
Several bad puns later.
There we go. Power and RF. So let's try again. Yeah, 47 watts from the kilowatts. Yeah, we've got a picture there. Let's have a listen to audio. Let's turn it up a little bit.
But that was a barroom brawl. That was a common pub fight, a shambolic drunken set to. Which you started. I just made an innocuous comment.
Yep, we have audio. We definitely have audio. The range is quite wide on this, so from there all the way.
When you were the four biggest mates, and then do your rope.
It sounds a little bit distorted right at the top end, but yeah, we've got audio. We have audio. So it's trying to work out whether that 18 ohms is good enough. So what I'm going to do is now take that one out and try a 700 ohm, something like that. Let's see what happens with that one. Oh, actually, let's have a quick look at the voltages. Let's have a look. So you can see the multimeter there. So we're looking at 29 volts. So we've got 78 volts on that side. 35 volts on that. So yeah, 29, 35, across to there, 35, 35 on this one, and then because it's going through the capacitor, there's a little bit of a drop to 29. So I think we can go higher. I think we can definitely go higher on that one. So so yeah, let's just, yeah. Let's just desolder that and put in 700 ohms. See what happens. 780 ohm resistor is in place. I think it's about 1 watt, half watt, something like that. So power's there. Power's on. Wait for the picture just so we know that everything's running. There we go. Let's try.
When the first woman landed on Pluto, or when they installed that gigantic.
That seems better.
It's just one of those things you always remember. Well, I don't. Good grief, you could hardly expect me to recall every single.
But I can smell burning.
What do you think I have?
Let's check the. Let's check the voltages. It could be the remnants of me soldering. So, yeah. Oh, let's turn it on to. Okay. Let's try there. 78 volts. 61. I decided to leave the 780k resistor in. Sorry, 780 ohm resistor in. Because when I actually felt it, it was barely warm. The vertical's a little jumpy, and that's just the control. But we're getting a nice tone from it. It's about the right. Oh, come on, stay there. Yep, it's about the right volume. Yeah, the vertical hold is a tad jumpy. Yeah, come on. There we go. Yeah, I just need to fix that control. But yeah, we're getting somewhere with this. We're definitely getting somewhere. So what I'm going to do is actually I'm going to put this thing back together again. And give it a clean up and run it for a while and see how it goes. I've got no idea what the resistor would be because I can't find the service manual. So if anybody out there has got the CTP, Sanyo CTP, was it CTP? Oh, come on. My brain has gone. Yeah, Sanyo CTP1101 service manual. I really appreciate it so I can check that resistor. This has just been purely experiment just to see what would happen. So okay, let's power this off, get this back together again, give that pot a bit of a clean with contact cleaner, and yeah, let's see what happens with it. So the TV is back together again, apart from the back and the speaker. Jack here has been watching me trying to fix all this, and he's now fixated on some sort of insect. I think it's in the UK they're called daddy long legs. Yeah, it's whizzing around up top. Apart from the slight vertical hiccup every so often, I think we're back to get working. So if I turn the volume up, that seems fine. It seems to be changing. So it was a bit louder there before. So I might need to put in a different resistor. If I can find that, if I can find out or find from the service manual what ohms resistor it should be, then that's great. It's currently got 60 volts going into that 2SC1507. Should it be line voltage? I don't know. You know, B plus voltage? I'm not sure. But for now, we do have a working telly. Jack seems to be quite impressed. So I'm going to get this back together again. I've actually given... Let's just turn that down. I've given the case a little bit of a clean on this side, not on that side. I don't know whether you can tell. Let's see whether I can get the ISO right. There we go. So I gave a clean on this side and not on that side, and it's looking all right. Yeah, it's working. It's running. The picture isn't particularly good. The dot pitch on this TV is pretty poor compared to other TVs, so I certainly wouldn't want to watch it for like, might work for gaming and stuff like that. But it's a very cute set. I've got to say, it is a very cute set. So okay, Jack, shall we shall we get this TV back together again? Yeah, let's get it back together again, and get the case on and then give it a clean. So there we go. It's back together. It's a nice looking set, it really is. It's got a pleasing shape. That's a little bit blown out. Let's just bring that back in. There we go. It's got a pleasing shape with all the controls on top. The aerial I've disconnected from inside. We don't need it anymore. It's just there for show. Yeah, it's really, really nice. It seems to be settling down. The vertical jump seems to be far, far less prevalent. I've used a magic eraser to have a go at trying to get rid of some of all the marks on the case, and it's done a fairly good job actually. Yeah, let's just wipe that down. It's not perfect, considering where it came from a scrap heap. Yeah, I am not surprised that it's got a few marks, but it is a very cute little thing. It's taken quite a bit of effort to get going, especially with all the cracks in the case and all sorts of stuff like that. So yeah, the AFT seems really does. That's actually slightly better, yeah. So yeah, so the case has got quite a few cracks and problems, and it still needs quite a bit of work. I am going to be doing a recap of this. I think this set is absolutely worthy. The dot pitch is pretty awful on this, I've got to say. It's not the best thing in the world. Oh, well, there we go. Oh, hang on. Oh, there we go. Gonna let it run, see how it goes. I'm going to also do a recap on it, try to find a service manual for it. I think this is definitely a keeper of some sort. Just the design, it's just so lovely, just so unique. Right, thanks for watching. Please like, share, subscribe, and I'll see you on the next video.